In this hands-on activity, we are required to look for a real-world problem, and this problem must be solved using flip-flops. So this one is a modified version of the solution I have created in the last hands-on activity. So this is the problem. For the past years, Agananpavia as a community has suffered the disastrous consequences of flood waters. Because of this, many lives and properties have been lost. The main cause of this problem is that river waters tend to overflow due to heavy or massive rainfall, storm surge, and tropical cyclone. So why is it still a problem until now? The Philippines is visited by an average of 20 typhoons every year, 5 of which are destructive. And although flood control systems were implemented, it does not guarantee that the community would be 100% free from flood waters. Being unprepared for a disaster produces a variety of negative impacts, such as loss of lives and property, loss of livelihood, and it also hinders economic growth and development. So I have created a solution for this problem. It is called the River Water Level Sensor, which is a nighttime system designed to alarm the residents for upcoming flood hazards. Again, this is a modified version of the one I had in the last hands-on activity. So in this system, I use 3 Ezer flip-flops, 3 NOT gates, and 1 AND gate. The switches on the left are the water level sensors, and the letter A represents the night sensor. Letter B is for the 50% water level sensor. Letter C for 70% water level sensor. Letter D for 90% water level sensor. We have 4 outputs in this system, and the first output is represented by the blue bulb, which means that the water is at 50%. And the second one is the orange bulb, which is 70%, and lastly is the red bulb, which is 90%. And together with the red bulb, the alarm would also turn on at 90%. So when the night sensor is activated, the system is ready to detect presence of water. When the night sensor is activated and the water sensor that detects 50% water would also activate, then the blue bulb would turn on. If the night sensor gets activated and the 70% water level sensor also turns on, therefore the orange bulb would also turn on. And similar to the first 2 scenarios, when the night sensor A gets activated and input D also gets activated, then the red bulb would light up, and together with this, the alarm would also activate. But because of the presence of the square wave generator, then the red bulb will blink when it activates. So the next one is a recording of the simulation that shows the blinking red bulb. For the feedback, I asked this question to my sister. And this is her response.